Good day. To- Today we want to look at the chemical properties of sulfur. I've told you to read on physical properties of sulfur and uses of sulfur. Now, I want us to look at the chemical properties of sulfur. Number one here, combustion. Sulfur burns in air with a blue flame to produce a colorless gas with irritating smell and turn blue litmus paper to red. The gas is sulphur oxide. You see the equation of reaction. Number two, reaction with hydrogen. When hydrogen gas is bubbled into molten sulfur, that is raw sulfur, in a test tube, a colorless gas with a characteristic rotten egg smell is evolved. The gas is hydrogen sulfide. Remember, if you put your raw sulfur in a test tube, remember it's molten, it's in molten form. When you put it in a test tube and you bubble your gas inside, there will be a gas will be involved, colorless gas will be involved, and the characteristic of that colorless gas is rotten egg smell. That is hydrogen sulfide. You see the equation of reaction. Reaction with carbon. Number three, when mixture of carbon and sulfur is heated in an electric furnace, the vapor produced condenses to form a poisonous and inflammable liquid called carbon 4 oxide and carbon 4 sulfide. Carbon 4 sulfide, that was the liquid we used to dissolve rhombic sulfur, if you remember the beginning of the note. Okay. Number four, sulfur as a reducing agent. Sulfur as a reducing agent in the sense that if you look at the equation of reaction where we have sulfur metal plus H2SO4, if you look at the product side, we have that we realize that oxidation number of sulfur has reduced to +4, but from the reactant the oxidation number of sulfur is +6. Because sulfur reacts with H2SO4, that has reduced the oxidation number of sulfur in H2SO4 into +4 in sulfur dioxide. So the sulfur here is a reducing agent to H2SO4. While the sulfur is oxidized, then H2SO4 is an oxidizing agent to sulfur. You can read on uses of sulfur. Oxides of sulfur. Sulphur 4 oxide, SO2. The two oxides of sulfur are sulfur 4 oxide, SO2, and sulfur 6 oxide, SO3. At room temperature, sulfur 4 oxide is a gas, while at room temperature, sulfur 6 oxide exists as a colorless liquid. Occurrence of sulfur 4 oxide. How it occurs. Sulfur 4 oxide is found during the combustion of sulfur and coal fuels. It is present in the atmosphere as a dangerous pollutant. Laboratory preparation of sulfur 4 oxide in fumed cable. From a triazonitrate 5 salt, crystals of sodium triazosulfate 4 are placed in a flat bottom flask and moderately concentrated HCl is added through a thistle funnel. The mixture is then heated. As the salt dissolves in the acid, there is effervescence. The colorless gas evolved is dry by passing it through concentrated tetraoxosulfate 6 acid or anhydrous calcium chloride. This is the experiment to demonstrate what we've seen earlier. You see, this is the test tube. This is HCl, which you pour here, and here you have your sodium nitrate. This one is your sodium trisulfide. Here is sodium trisulfate. Sodium trisulfate. When this HCl is added to it, there's going to be involved and heat. There's going to be involvement of gas, which will follow to this. We have our H2SO4 here, and you should know that this one serves as a dry agent, dehydration. The H2SO4 is a dehydration. It removes water molecule from the gas to give us dry dry SO2. We have the gas. You should know that the gas is collected by downward delivery since it's heavier than air, or upward displacement of air. That is that. See the equation of reaction. You can also prepare it through concentrated tetraoxosulfate 6 acid. Good. But one point you should know here is that sulfur, carbon, silver, or mercury can be used instead of copper. We have industrial production of sulphur 4 oxide. Sulphur 4 oxide is produced in commercial quantity by the combustion of powder raw sulfur in air. You see, this is raw sulfur, and this is oxygen, which combine to form sulfur dioxide. The gaseous product is stored in cylinder for industrial use. Physical properties of sulfur. We have physical properties of sulfur, but I only remove just one. It is very soluble in water, hence can be used to demonstrate the fountain experiment. Remember, ammonia was used to demonstrate fountains in experiment because it is soluble in water. The same thing, since sulfur dioxide is soluble in water, it can be used to demonstrate fountains experiment. Chemical properties of sulfur dioxide. Action on litmus paper. Turn most litmus paper red. And then combustion. The gas does not burn or support combustion. Reducing properties. SO2, sulfur 4 oxide, can act as a reducing agent. When the gas is bubbled into a solution of acidified potassium permanganate, the purple color is reduced to a colorless solution without a deposit of sulfur. You see the equation of reactions. In this equation of reaction, we have the oxidation state of manganese is 7, and from the product side, oxidation state is 2. So this sulfur dioxide has caused this manganese to reduce from 7 to 2. So sulfur dioxide is a reducing agent, while this one now is the oxidizing agent. Okay, sulfur dioxide as an oxidizing agent. That means it behaves as a reducing agent and the oxidizing agent. Sulfur dioxide can act as an oxidizing agent. You see the equation of reaction. If this is magnesium, oxidation number is 0. Here, oxidation number is 4. Then from the product side, we now have oxidation number of magnesium has increased from 0 to +2, and the sulfur 2 has reduced to 0. So this one has oxidized the magnesium, and this magnesium has reduced the sulfur to 0, from +4 to 0, while this one has increased in the oxidation number from 0 to 2. Hence, this one is the oxidizing agent to this, while this one is a reducing agent to the sulfur here. The same example, this is SO2 plus hydrogen sulfide to give us water, and this is the one I gave you for your assignment in Google class. This is it. You can write this in your note. I've told you it is written there. I've told you tetrasulfuric acid H2SO4 is prepared by contact process. You see the equation of reactions? We've carried out this before.